Okay, everybody, this video finishes up Chapter 9. It's in the homework and notes as 9.3. And it has to do with the types of errors that can occur when you're doing a hypothesis test. So we're not doing any testing here. We're just talking about what could go wrong. There's two classifications of errors. So there's two things that can happen. Either the null is true or the null hypothesis is false. Right? If you recall, remember doing our hypothesis testing, there's some sort of null base assumed to be true claim, like the mean of some population is 50. And then there's an alternative to that, which maybe it's that the mean is, that we think the mean is actually bigger than 50 or something. So again, two things happen. Either this null hypothesis is true or it's false. Okay. Now, depending on our test that we perform, and really what it kind of depends on is the level of significance we decide to use, because that's ultimately the threshold for when we decide to reject or not reject the null. Two things can happen. The null can be true and you might reject it. Okay, so maybe this guy is true, but our test said, get rid of it. It's not true. Go with the other guy. Go with the alternative. Well, that would be wrong, right, if the original guy was true. And that is what is known as a type 1 error. Okay, a type 1 error is when you reject the null but shouldn't have. Okay. The correct thing to do would be to, if the null is false, then the correct thing to do would be reject it. Get rid of it. All right, that would be the correct thing to do. But if you were to accept it, that would be known as a type 1 error. Okay. The other scenario that can happen is maybe the null is false. So maybe this is false, it's wrong. That truly the mean is not 50. The correct thing to do would be to reject it then, right? So the correct thing in this case would be get rid of it. Get rid of the null. Okay, because in this case, the null is false, so we hope our test makes us get rid of it. The wrong thing would be to fail to reject it. Right? Fail to reject it means we're not going to get rid of it. So a type 2 error would be where this thing is false, and what we do is we say, we miss it, and instead we leave it alone, and we basically, it's not like we reject the alternative, but there's no need to think other than the null hypothesis. So we go with the false answer. So this is where we do not reject, but should have. Okay. So the whole point of this section is to basically kind of just help us get an idea of those two types of errors that can occur, to be able to identify them. And that's it. So again, here they spell it out, in words. Type 1 error is a false rejection. You rejected the null, but it was actually correct. So you rejected when you should not have. Okay. A type 2 error is is a false failure to reject. So we did not reject the null. We failed to reject the null hypothesis, but we should have done it because it wasn't true. Okay. So it's sort of like in this first one, we got rid of a true answer. And in this one, it's like we accepted a false answer. And if you think about it that way, if I were to ask you which one of these is worse, which error is usually probably worse, I suppose it would maybe depend on the scenario. But I think for most things, this is going to be the worst error. Okay. Because the type 1 error, again, it just means that we had a true answer, but we got rid of it. Well, that's a bummer, but maybe not going to cause any serious issues. Type 2 can cause some serious issues if you accept a false answer as true. Okay, that can cause some serious issues. If we're testing to see if, some safety feature is reliable and it's not, but our test tells us that it is, that's a problem, right? So anyways, what they do for the next 3 examples, this is a nice short sweet video, is that they give us a statement. They want us to set up a null and alternative, and then just classify or write out what the 2 types of errors would look like under this scenario. So here, this first example, it says 10% of all people write with their left hand. Okay, so if I needed to write a null and alternative to that, maybe I'll just come off to the side and do it. Again, the null hypothesis is the baseline assumption, the status quo, the claim that's being made. So the claim is that 10% of all people write with their left hand. So this is a percentage or proportion. So the proportion of left-hand writers is 10%. Now there's no indication of whether or not the alternative would be hinting at more or less than that. So the alternative to 10% of people writing with their hand or left hand would be 10% do not write with their left hand. So this would be the null and alternative hypotheses. So what would a type 1 error look like? Again, type 1 error is when you reject the null, but it was actually correct. You shouldn't have done it. Okay, so I'm going to just take that note. So we reject, but shouldn't. So my conclusion then would be, if I reject the null, I'm saying you're not right, I'm going with you. All right, that's would be me rejecting the null. So I would say my conclusion would be the proportion of left-hand writers is not 10%, or 0.10 of left-hand writers is not 0.10. Right? That's me saying, nope, you're wrong. I'm rejecting the null, and I'm then going to go with the alternative. But because I'm making a type 1 error, I rejected, but I shouldn't have, meaning that in reality, it's true that actually 10% do write with their left hand. All right, so again, that's me rejecting when I shouldn't have, because it was actually true. All right. So let's think about what a type 2 error is. A type 2 is where I fail to reject the null, but I should have, because it's false, it's not true. So this is where I don't reject, but should have. Right, because the null is false. And I failed to capture that in my test. So I do not get rid of the null. I say, hey, all right, you're okay, null. There's no reason to think otherwise, when in reality it's false and I should get rid of it. So what I end up doing is I say, you're okay, and I say, I'm not going to mess with you, but that's completely backwards. I should be getting rid of the null and accepting the alternative, or going with the alternative. So again, this is where I do not reject. So if I don't reject, my conclusion is that 10% of people write with their left hand, because I'm taking the null for what it is. I'm not getting rid of it. When in reality, I should have gotten rid of it. The null is false. In reality, that thing is no good. And so in reality, it is not 10% of people that write with their left hand. Okay. All right. So again, these can be tricky to remember, but type 1 is when you reject the null, but you shouldn't have. We get rid of the null, but it was actually true. And then type 2 is where we do not reject, but we should have. The null is false. So maybe here I'm just going to add up here. Type 1, H0 is true. And the error is that we get rid of it. Type 2, the null is false. And the error is that we do not get rid of it. Okay. All right, let's take a look at this next scenario. Same thing, just given a situation, state the null and alternative hypotheses, and then write out what these two errors would look like. So it says that a hardware manufacturer needs to keep a defect rate of 0.01 or less in order for their shipments to be approved. A sample is taken from every shipment, and the shipment is approved unless there is evidence that the defect rate is significantly higher than 0.01. A sample of a certain product, is found a defect rate of 0.017. Okay, so get the idea here. They're shipping out a bunch of things, whatever they are, nuts and bolts or something like that, and they are okay with a defective rate of 1%. So they need 1% or less of their items to be defective in order to approve for shipment. Okay, so they take samples of shipments every now and then, so not looking at a whole shipment, but just a small sample. And in this one particular one, they found a defective rate of 0.017. So that doesn't mean that the shipment is bad, right? Or it's just that the sample they got happened to be bad. So again, it's another one of those things like, there's a true percentage of defective products. Maybe their sample was just happened to be a high sample. Okay, and so just because it's up here doesn't mean that we necessarily reject that notion. It depends on what our hypothesis test says. So anyways, let's state the null and alternative hypothesis. The null would be that the percentage or the proportion of defective, what am I trying to say? The defective rate is 1%. So the percentage of defective parts is 0.01, right, or the proportion of defective parts. The alternative, well, let's see. I think what we're concerned with is if we have anything higher than that, right? If it turns out that our defective rate is higher than 1%, then I'm not going to send the shipment out. So I think that's what we're looking to test, to see if we get a higher defective rate than 0.01. All right, let's think about what these errors look like. Type 1. Remember, type 1 is where the null is true, right? But we accidentally get rid of it. Okay, so in the type 1 error, this is true. But for some reason, our test told us to get rid of it. So our conclusion, our step number 5 would be we get rid of the null. We reject the null and go with the other guy. So our conclusion, again, our step number 5 would be we reject the null. Probably should have wrote that on the first one to make it a little more clear. The defect rate is higher than 1%. When in reality, the null was true. So in reality, the defect rate is okay. It's within 1%. Or it's not greater than 0.01. Okay. So that would be a type 1 error when we got rid of the null, but it was actually true. All right, we got rid of the null and went with the alternative, but we didn't need to do that. The null was telling the truth. Type 2 error is when the null is false, but we take it anyways on accident. So type 2 error, this guy is false, but for some reason we accidentally accepted it as the answer. So I accepted it. I did not get rid of it. And so my conclusion, the results of step 5 would be we stick with the null. We don't get rid of it. We fail to reject the null. So our conclusion would be that the defect rate is within 1%, or again, it's not the alternative. It's not greater than 1%. All right. When in reality, the null is false, right? So we fail to get rid of it. We take it, we accept it, but the mistake is that it was wrong. We should have gotten rid of it. So when in reality, the defect rate is actually higher than 1%. Okay, that would be the issue with the type 2. So this question says, well, which is worse for the consumer in this case, a type 1 error or a type 2 error? Well, let's think about the type 1 error. What they had, in reality, the defect rate was within 1%. So in other words, the parts were good. It was okay to be shipped. The parts were good. It was not going to cause any harm. What they ended up doing is they ended up not shipping it out because they made the mistake and they thought that the defect rate was actually higher than 1%. So they chose not to send the products when actually they were okay to be sent. That hurts the company. That doesn't hurt the consumer. Okay, it just means that the company had products that were okay to send and they didn't send them, thinking that they were not okay. Now the type 2 error is bad for the consumer because in the type 2 error, they shipped it out, right? They did not reject the null. They felt that the defect rate was within 1%, so they shipped the defective nuts and bolts off to whoever, okay? When in reality, they were more defective than 1%. So that's bad for the consumer, okay? Because again, the company didn't catch that they were defective. They thought they were okay, so they sent them, when in reality, they are more defective than what they should be allowed. Okay, so in this case, it's the type 2 error is worse. Okay. All right, the next page has one more of these, and then they talk about the idea of power of a test, and then we're done with this one. So let's take a look at that. Okay, here's the last scenario. It says a school claims that 40% of its seniors are attending a UC or Cal State next year. John thinks this estimate may be wrong, so write the hypotheses John should use to test this claim, and then explain what a type 1 error is in this context. So again, these schools claim, school claims 40% of its seniors are going to go to UC or Cal State next year, and John thinks that estimate may be wrong. Okay, so the null hypothesis, again, we're not doing means here, we're doing percentages. So the percentage or proportion of students that the school claim are going to UC or Cal State is 40%, or 0.40. The alternative that John wants to test is he just thinks that they're wrong. Not that it's more, not that it's less, just that they're wrong, so that it's not 40%. So that would be my null and alternative hypotheses. So then what would a type 1 error look like? Remember, type 1 error is when we reject the null, but shouldn't have. Okay, so we reject the null. So in that case, John is going to say, nope, I'm not going with null, I'm going with the alternative. So John rejects the null hypothesis and thinks that not 40% of seniors are going to UC or Cal State. All right, but in reality, he made the mistake. He rejected the null, but in reality, he shouldn't have. It was true. So he said, no, I'm going with the alternative. I think that it's not 40% of seniors that are going to UC or Cal State, when really it is 40%. Now, errors are important to be aware of because they can have serious ramifications. I don't think anyone's getting hurt as a result of this test. But you can imagine when it comes to quality assurance or testing safety features, infinitely many other things, it's really important to be aware of the types of errors that can happen. Okay, the last idea here is the concept of a power of a test. And we don't go heavily into this at all, really. We just kind of want to highlight these two ways that we can make our tests powerful. And what it means to be powerful is it means that if the null is false, then we correctly get rid of it, right? So the likelihood of that happening, the probability of us doing the right thing, getting rid of the null when we need to, when it's false, okay, that's known as the power of the test, okay? So it depends on certain things, like it says that the power of a test depends on the true value of our parameter, which we often don't know. But basically, the more powerful we can make our test, the better, okay? And so here they give us two ways to make our test a little more powerful. So one is, don't use too low of a significance level. Um, 5% is good. Or use 10%, okay? So I'll say or higher. But again, what we're trying to do is we're trying to make sure that we correctly reject the null. We're trying to not do a type 2 error, because type 2 errors could potentially be the worst, okay? We're trying to not, we're trying to get rid of a false null as opposed to keeping it, all right? Type 1 error doesn't necessarily, may not cause too many issues. I guess it depends on from the context. But again, what we're trying to do is if the null is false, then we want to get rid of it, okay? So in other words, we want to try and make it hard to accept it, okay? We want to make it easy to get rid of the null. So when you find your p-value, remember, you get rid of the null if your p-value is below the tolerance level or our threshold, okay? So if your p-value, which again is the likelihood of some event occurring or gathering the data we did based on the claim or based on the null assumption, if that is very low, it basically again means that that was unlikely for us to get that data, but we did get that data. So that makes us think we should reject the null hypothesis, that it's wrong. If the p-value is less than your alpha value, you reject. Well, if you make your alpha value too small, then you can have really low p-values, and so you should probably be rejecting the null. It's probably that the null is false, but because it's not lower than this ridiculously low alpha or significance level, this threshold, we end up not rejecting it, and we end up keeping the null hypothesis when it's probably wrong. So again, we want to make it easy to get rid of the null hypothesis so that if there's a chance it's wrong, we don't take it. And so one of the best ways to do that is to use not too low of a level of significance. Again, if you think of the problems you've done with hypothesis testing, if this was your alpha level, there would have been very few problems where you would have rejected the null hypothesis, because to get a p-value lower than this would be pretty hard to do. Okay. All right, so the other thing we could do is just increase our sample size. Basically, make sure we're using as large a sample size as we can. Bigger sample size makes all of our estimates more accurate. Okay, everything we estimate becomes more accurate by increasing our sample size. Okay, so that's always just a general good thing to go about if we can. All right, the main takeaway there, I would say, is don't use too low of a significance level. If your significance level is really low, okay, then you're not going to be rejecting any hypotheses, okay, because it's going to be hard to get a p-value below that. So you're going to end up not rejecting things, which means you're going to accidentally be taking hypotheses that are probably false. We want to make it easy to reject. All right, shortest video on the lesson. So here we're done with this. We're done with chapter 9. I'll start videos on chapter 10 shortly. And chapter 10 is literally a repeat of chapters 8 and 9, but with 2 samples as opposed to 1. So very little changes other than when we have to check for IRL. Now there's twice the things to check. And when it comes to writing or finding our test statistic or building our confidence interval, sort of the size of the formula basically doubled. Okay, that's okay. That's even more motivation for us to do it on StatCrunch. So chapter 10 will be very familiar, and so will the rest. You guys are there. You're on the downhill stretch. Good job. Talk to you guys soon.